Okay, thank you for coming. My name is Luis Valencia. I'm a Microsoft MVP in Office and SharePoint. And today we are going to talk about cognitive search. Before going forward, so thanks to Satellite for the space here and for the catering. I hope we can continue coming here in the next sessions. Who am I? So I'm a solutions architect. I work at PwC. I have 18 years of experience in software development, and lastly, the last 5, 6 years as cloud architect. I just founded the Brussels Developer User Group. So this is the first meetup we have. I encourage you, if you want to speak about any topic related to development, just contact me. It doesn't have to be Microsoft. It can be related to Java, React, Angular, Google technologies, Amazon technologies as well. I created in the last couple of weeks the social networks. So feel free to follow us on Twitter, Facebook, LinkedIn, and if you are here, you probably know already the Meetup group. In 2 months, in April 2, we have the second meetup about machine learning. So, with two sessions, the first will be an introductory session, and the second will be a custom demo using machine learning in Azure by Nick Trow from Microsoft. This time is going to be in the Microsoft offices in Saventem, and we have 100 seats for this one. So feel free to join the group as well and to share it. So let's talk about cognitive search. So what is cognitive search? Is search as a service. Basically, you don't have to create any infrastructure. So you only have to create an Azure resource and start adding content to it. We'll see in the demos how it works. It's really easy. You can create multiple indexes. You can consume it from Java applications because it's use a REST API, the consumption, as well as the indexing. So benefits. So we can add multiple content types. So you can index Word files, doc files, PDFs, pictures, audio, video, as much as you want. At the end, the index is only JSON documents, so you can create custom JSON objects into the index. We can leverage artificial intelligence algorithms to recognize content. We will see that in the last demo of tonight. We can use filters, synonyms, autocomplete, and text analysis. So basically, if you type something and you don't know how to type it, you misspell it, then Azure Search will get the results anyway. We can create search apps for specific use cases, and one of those use cases is actually GeoSearch. So searching what's around me, for example. That's what you do in Bing, in Google Maps, for example. So we can do that kind of scenarios as well here. Core search features. So we have free form text search. So there are several ways to search. So just type in a query term like you do in any search engine, but you can also use a specific syntax operators. So you can use and or you can use advanced operators like search proximity, for example, fuzzy search, term boosting, and regular expressions as well. We have relevance. So everything you type will match the index, but Azure Search will give a score based on what you try to search. So the score is a number between 0 and 1, 1 being 100% what you're looking for. And we can, as I mentioned before, we can also use GeoSearch within the index as well. Other features, we have facet navigation and filters. If facet and filters are correlated within each other, basically facet means that you will have some properties in your index. Let's suppose you have an index about products like Amazon, and you have brand. If you are selling computers, you have brands, RAM, hard disks, things like that. By sending a parameter to the REST API, you will get the filters that you can filter down more the results. So you search for laptop, and then you will get on the left side that you can filter by price or by brand or by the size of the hard drive, for example. User experience features, uh, autocomplete, search suggestions, synonyms, hit highlighting, sorting, and paging. I think they are very self-explanatory, except hit highlighting, probably. So hit highlighting is whatever you type in the search box can be highlighted in the results so that you can easily find it. Autocomplete and search suggestion is, I guess you already know it, is when you type on Google and Google try to find, or Google already knows what you want to find. AI features, so we have cognitive search and knowledge store. So cognitive search is basically enriching the content with AI algorithms. So if you want to index pictures, for example, with cognitive service from Azure as well, uh, we can recognize what's inside the picture. We can recognize people, buildings, text via OCR. So we can connect Azure Cognitive Search with an external service to enrich the content that we want in the index. And knowledge store, that's in preview right now. And it means basically whatever we enrich, we store it in a blob storage uh, for further improving the algorithms using machine learning. So if you have 1 million pictures, you store them in the index for Azure Search to work. But with Knowledge Store, we store them in blob storage to help you improve your machine learning algorithms later. About data importing and indexing. So Azure supports out of the box different data sources. So we accept Azure SQL, Cosmos DB, and blob storage, or we can even connect to SQL Server on a VM inside Azure. So you can index tables from SQL Server or from Azure SQL. We can index containers in Cosmos DB, and we can index blob storage, and that comes out of the box. You don't have to develop anything. So it's just a wizard that you select the data source, then you select the schedule of the indexing, and that's it. You don't have to do any coding. However, there is something called the push API, and that means that you can basically index anything you want. For example, a file share, Google Drive, SharePoint sites, and what's how does it work? So it's just an API. You call an endpoint with whatever you want to index, and that's it. One example would be you create a console application that runs on a VM, and what it does, it goes through the files on a file server on a file share, and then you push it to the index. Yeah, so you can index any type of content in this way, but you have to develop a, let's say, the connector, which can be done console application, an Azure web job, an Azure function, but it's just calling the REST API. Hierarchical and nested data structures. So because the index at the end is only JSON, is not a flat structure. That means you can index any complex object you want. Later you will see in the demos that we are indexing information about hotels. So a hotel room has many different features. Is not the number. Is not only the number of beds, but you can also have amenities, swimming pool, spa, things like that. And in linguistic analysis, so basically with cognitive search, we can improve whatever the user types in the search box. So even if the user mistypes something, then with lexical analysis, we can find out, but this is automatic for us, whatever they are trying to do. So let's go to the first demo, provisioning an Azure search service. That's very easy. So we are in the portal. It's important to note that a few months ago, Microsoft renamed the service. In the past, it was Azure Search. Now they call it Azure Cognitive Search. So maybe you are looking for documentation uh, on blogs. You should search in the with the previous name. You have it here in the marketplace. So it's pay per use. We only need to select the resource group, put a name to it. I'm not going to create it because we already have one, but I want you to see the pricing here. So you can play with this for free. The only limitation is you can only create 3 indexes, and you can index maximum 50 megabytes. There is also some limitation in performance with partitions and high availability with replica. So there is only one on one. But if you want to use it in production, so I encourage you to use a standard S1, S2, S3. It depends. Something to keep in mind is you can't scale an Azure search. After it's created, you can go, if you create it in S1, you can't go to S2 or S3. So you need to migrate the index. So that's something you need to keep in mind when you are planning the service you want. After it's created, so it will take some minutes, you will have something like this, where we have the storage used, the number of indexes, the number of indexers, and the number of data source created. We will go in a minute. So, second demo is how can we index data using the out-of-the-box connectors. So here on the top, you see import data. And here we can connect to any of the Azure connections we have in the subscription. So I'm gonna tell existing data source, Cosmos DB, for example. I'm gonna select a connection. So if we have 10 Cosmos DB, 10 Azure SQL, all of them will be here. I put a data source name. I select a container, and then I need to type for Cosmos DB. I need to type the query, which I have here. You can filter even if you have a table with 1 million rows. You can decide with where clauses if you want to index everything or not. Share. Validating at the moment, and it's going to try to figure out what properties do we have in that data source. So you don't need to create a schema for the index. It will try to infer the schema for you. I'm going to skip the cognitive skills for now. What I want you to see is the custom target index. As you can see here, it will try to find the properties we have in that data source. And then we can decide what we want to be searchable, filterable, sortable, and fastable. If you work with SharePoint maybe in the past, it works the same way. So basically in SharePoint, when you create a library, for example, you can select what properties you want the people to use in the search. So I'm gonna select partner name, partner contact, everything here, and I think I need my cable, and I will create the indexer. Here I can put the schedule, so hourly, daily, custom, and when you select custom, the maximum or the minimum uh, schedule is 5 minutes. You can push it every 5 minutes. Different data sources work in a different way to index updated content or new content. For example, with blob storage, you need to have a field last updated so that the next time the indexer run, it should pick up only what changed, not everything. Okay, 1 minute. I'm going for my. Okay, then we can go to indexes and we can see the document count. So this hasn't finished yet, but I can go to one of the other indexes already created and you will be able to test the index with any term you want. So we will see this in a minute in other demos. It's giving some results. So let's talk a few minutes about a full text search and the architecture. Wait a second. So the architecture for the search, it's really simple. The user types something, then there is a query parser which will analyze or will get the search terms, will split the search terms, will send them to the analyzer, There are several analyzers to check for consistency in the phrase you type. It will try to improve whatever you type. It will get the analyzed terms back to the query parser. Then it will send what we call a query tree to the search engine, to the index, and then it will get the results. At the end, there is a scoring algorithm. So it's not just returning the results, it's returning the best results. So that's what we have here in this slide. So let's go to the demos related to coding. So this is the first demo, and this is the basic search. Here, I'm not using the REST API directly, but I'm using the Azure Search SDK. So you can just install it as a Nugget package, and then you can start playing with it. At the end of the session, there is a link with the code samples from GitHub, so you will be able to download yourselves and play with the code. So the first thing we need to know is where are we searching, and that's in the app settings JSON. So there is the search service name and then the API key that will allow us to connect to the index we want to use. Then this is an MVC application. So basically we are trying to we create a search service client with the name and the API key. Then we create an index client, and basically we are getting a reference to the index we want to use. It's important to know here that any search uh, goes against an index. So even if you create 10 indexes, you have to select the index you want to query. So if you want to create, I don't know, an index with pictures, another index with documents, another index with information from SQL tables, and you want to join them all together, then you have to do it in the code because every query is different for every index. Then with the index client, we use the search async method with the text we want to search, and then the parameters. The parameters is probably the most important parameter from the search async, because here we define the behavior of the search. As you can see here we are only returning the hotel name and the description, but you will see in the other demos how complex we can make the search parameters. So see if we have here, yeah. So nothing too fancy. I'm just searching using the code I just showed before, and I am returning the title of the or the name of the hotel and the description, and that's it. For a second demo, let's talk about paging. So in the init search is actually the same code, so you don't have to worry about doing everything again. The search is exactly the same line of code that we put before, and the only difference is this parameter object. Here we are saying we are setting the search mode to search for everything in the text index, and here we are doing the paging in the index itself. So we are not doing the paging on the front end. So we have the skip and what how many results to return from the index. And there is an additional parameter about the total count. So if we go to, I'm gonna close this one, number patient, nothing too fancy here. Then you have the patient on the bottom, and yep, it's failing. But let's try again. The user interface is developed by you. So there is an SDK, a .NET SDK, but the paging and everything, you have to do it with HTML and any framework you want. It can be used jQuery, Angular, React. And okay, yeah, it doesn't get any paging because it's three results. Yeah, here we go. Yep, and that's it. So what we are doing here is just calling the controller with the page number and how many results to return. That's it. Infinite scroll. So this is a combination of, let's see, this is a combination of front-end code with back-end code. So like you do in Facebook, when you start scrolling, or in Twitter, the server side, it will be impossible to handle everything you want to see in one go. So there is an event here in the mouse, which all browsers support. Basically, when you go to the bottom of the page, you are calling the API again, and that's pretty much it. So when the function, when the scroll is executed, then we call the get JSON in this API home next. If I go to the code, we have a next controller, and then we query the index again. Yep. But the index, or the search, is basically the same we did the first time. Document.search async. So the backing code, my message is, the backing code is exactly the same. The only thing that changes is the front end. Next demo, type ahead. This is very interesting. So there are two demos I want to show you here. And I lost the window. Okay, results. Type ahead. Okay, so there is type ahead and suggestions. It's two different things. And those things are based on what you have in the index already. So if I type two letters here, it will try to complete what I'm trying to search. In this example, it's secret, and this autocomplete is based on the index of hotels we have. So if you have a different data in the index, then the autocomplete will be there. And the other thing is the suggestions. So the first thing is the autocomplete, and the second is the suggestions. If you see the network tab here, you will see is calling the autocomplete and suggest here with the term, and then in the response you will see it will get the what you typed here, plus the suggestion plus the autocomplete. And how is that done in the code? Let's check. There is a method here, autocomplete and suggest. And this demo is actually different to the previous three because we are not calling the search async method. We are calling the autocomplete async and the suggest async. So that's a bit of a difference. So here we have the autocomplete results based on whatever we were typing in the search box. And below you will have the suggest. And then this is just a standard link queue to join the results together. Yeah. Facet navigation. So let's close this and let's talk about facet navigation. So as I explained in the beginning, facet navigation and filters is what you see on the left, depending on the on whatever you have in the index. Azure Search will return the categories that you can use to drill down into the results. So I'm going to do it empty. So if I search for swimming pool, for example, automatically it will get the filters that you can use. In this example, with one result, it doesn't make any sense. Let's see with something else. So if I am searching for hotels with a spa, then on the left side you can see category and amenities. Then I can drill down to, I don't know, hotels with a spa and free Wi-Fi. Then you have it. So how is done in the code? That's also simple. As I said multiple times already, the most important parameter here is the search parameter. And if we want the API to return the filters we want to use, we just select or we just add this property facets with the filter name and the maximum number of filters we want to see on the left side of the navigation. And then we add the filter, and this is when you type, when when you select one of the filters, it will concatenate in the query string so that you can drill down in the search results. So if you see on the top, you have facet, amenity filter equals tag and something. Yeah, you see there is a any on the top. So basically, it will search results with free Wi-Fi in any of the columns or the fields. And the search is basically the same. So it's search async as we saw in the previous three demos. So the only different demo here is the one with autocomplete and auto suggest. Finally, order results. So I think is this one. We can define our own sorting. So by default, Azure Search returns based on the scoring profile. So as I said in the beginning, I'm gonna see if I have it here. When we query something, we will get a score for the results. And by default, it will show the results in this order. But by code or the results, you can customize the sorting. In this case, in the front end, you can see we can sort by numerical rating, by amenities, by the renovated date. So we have it here. We have a switch with a case, and then we change the syntax of the query for the order by to work. Yeah. So here you see we have a scoring parameter with the amenities, and then in the bottom down you will see scoring profile and scoring parameters, and that's pretty much it. The search async is exactly the same. Now the fun part, let's talk about artificial intelligence. So as I said, yeah, as I said before, so we can utilize AI into the index. If we connect to a blob storage, and in the blob storage you have PDFs, you have pictures, we can get rich data about it. You will see it in a minute in a demo. So Azure Cognitive Search will connect to the data source. It will get the binary file, and then it will send that binary file to Cognitive Services. So in Azure Cognitive Services, there is an API for computer vision and another for text analysis. So basically, uh, with the computer vision, it will try to recognize what's in the picture or in the PDF. So buildings, people, if the person is wearing a blue suit or things like that, it will try to recognize it, and then that information will be enriched in the index, and then you can search for it. And that's pretty much automatic. You don't have to do any coding at all. However, you can create custom skills. So by default, you have these two skills, computer vision and text analysis. With text analysis, you can recognize company names, people's names, but with custom skills, you can enrich it even more with the custom code. So you can create any custom code to do something you dream about. So go to the cognitive search demo. So before coming here, I put some pictures in blob storage, right? So I guess you know who is this guy. You can see there is also text in this picture, and he is wearing a red shirt, right? Let's go back to here. I'm in the index. Yep. If I search for Scott Guthrie, who is the guy on the picture, you will get the results we want. So basically, because he is a celebrity in the Microsoft world, then with computer vision, the cognitive search will recognize the person. And as you can see in the values, you can see it will enrich the index with some information like person, human face, clothing. Then you will see in image caption, Scott Guthrie standing in a room. We didn't do anything. This was done automatically. Yep. If you see the picture, there is some text like advantage. Let's try to search for it. I hope it works. Yeah, I'm gonna refresh. Okay. So here you will see more data enriched by Cognitve API. You will see here artifact advantage of and whatever he tried to OCR from the picture itself. And you can even see what is called the bounding boxes. So using pixels, it will find text in the picture. So probably you won't use this, but you can see also image tags here, image caption, and content. In this case, the Cognitive Service API enrich this with information from Microsoft because he knows Scott Guthrie works for Microsoft, so he added some information about probably the stock exchange for Microsoft company. Then you can use even a search for Microsoft and you will get the image even if in the image you don't see Microsoft anywhere, right? Probably the score will be lower because it's not in the picture itself. And that's pretty much it. So here is the link to download the code for the demos. Please follow me on Twitter, check my blog. This demo is recorded, so I will upload later and I will put a link in the Facebook group, in Twitter, in LinkedIn, and in the Meetup group as well. Thank you.